So I'm going to invite the VISTA Award finalists to the stage to get ready, so you guys can come on. So VoLo's trustees, David and Thais Vogel, understood that change stems from innovation and action. And so this year we implemented an award to honor the student that displays leadership, innovation, and adaptation in climate solutions within the state of Florida. So we invited these 4 students to pitch their solutions to you here today. Each finalist will be given 5 minutes to pitch her idea. Yes, her idea. We have a panel of 4 female scientists here, so that's exciting. And we invite the audience to help us in the judging. So you'll see up here on the screen that there's a link you can type into your browser, and it will take you to one page to vote for the solution that you feel should be supported for next year to scale here in Florida. And then we also have a different panel of pre-selected judges that will also be doing some scoring. So we're going to take the average of both the judges and the audience's scores and find the winner for today. And that will be announced this afternoon at 4:30. So come back for that, please. And just a note, the voting for the VISTA Award for the audience will be cut off at 3 o'clock today. So by 3 o'clock, if you haven't voted, we're sorry, but we have to count votes. Okay, so I'm going to hand it off to the panel, and thank you so much. So first, Nadia, go for it.
Good afternoon, everyone. My name is Nadia Cedaram, and I'm a PhD student at Florida International University. Oh, perfect, great. One slide too fast. There we go, perfect. Is there clicker? Is this it? Great. Perfect, thank you. Great, so my presentation is titled Changing Coastlines, Understanding Risk and Realities of Sea Level Rise in Miami. No? Got it. No, there's a red arrow. Oh, wait. No. Got it. Yep. Sorry. So my presentation is titled Changing Coastlines, Understanding Risk and Realities of Sea Level Rise in Miami. But that's just the title. I want to talk to you today about our collective future here in Florida, because what happens in Miami-Dade County, featured here, affects all of us in the state and even outside of our state. And so I'm going to show you some sea level rise projections, and I know it's sometimes difficult to think about sea level rise because it's still such an abstraction to many of us. So I want you to think about it as occurring within a single lifetime, Alicia's lifetime, who's featured on the left. And Alicia was born in 2004 on Miami Beach, and that's when sea level was still pretty stable. But by the time Alicia is 26 in 2030, which is just a decade away, Miami is projected to have experienced 1 foot of sea level rise. And you can see some of that inundation, if you didn't see it before, occurring in that southern region there. You'll also notice some inundation pockets in the inland and low-lying areas and along the Atlantic coastal ridge, which is, you can just sort of make out that bump, right? That bump right there, those ridges. Those are the highest points of elevation in Miami, I should also point out. By the time Alicia is 56 in 2060, there's a good chance she's not living in Miami anymore, because Miami is projected to have experienced 2 to 3 feet of sea level rise by then. And still within her lifetime, beyond 3 feet of sea level rise, Miami just looks very different. Again, you can see those pockets of inundation occurring even inland, sort of breaking up that ridge as well. And if you look closely, Miami Beach is really just a sliver of what it once was. And so my question today is, well, where do people go? What does this state look like if this is the future of South Florida? Are they going to be migrating to those higher points of elevation? and displacing the current residents of those areas, for which portions are there are currently communities, marginalized communities, historically marginalized and underrepresented communities living there. And if they get displaced, well, where do they go? Do they go to low-lying areas where they'll face vulnerability again? And that's what we call climate gentrification in Miami, and it's arguably ongoing. And so we know that this is occurring. You know, we have headlines from 6 months, 2 months, 2 weeks ago. We know that this is occurring within a single lifetime. We know that and also that is barring any major hurricane event, right? Because we all know and have sort of seen from in New Orleans after Hurricane Katrina, there was unmanaged migration. And so these conversations, they're always sort of occurring in this post-disaster context. You know, we only really talk about these things after a hurricane has hit. And that's when we sort of consider whether or not we're going to leave or retreat from our coastlines. But if we know if it's occurring, why aren't we talking about it more proactively? And so that's my solution. Let's talk about it. I propose the first set of focus groups within communities that are facing climate gentrification and within communities that are facing inundation. Why? Because we need the policy. If we are to manage this, then there's more than just homes that are being lost. There's communities that are being lost. There is a sense of place, of culture, and we need to build buy-in from these communities as they face probably the most difficult choice that they'll ever have. And so I have lots of questions for communities, and I spent my summer attending community meetings, and they just sort of, it sort of rolled up into all of the different questions that I saw unaddressed. Do you want to leave now, but you can't? And where would you go? Would you come here to Orlando, which is a lot of what a lot of experts sort of suggest that, or would you go to Atlanta, another place where experts are suggesting that people might go? And if that happens, if there is a mass migration, then what's the responsibility of South Florida's governments to governments here in Orlando or in Atlanta? How do governments facilitate that migration and then that need from all these people who need services in these in cities like Orlando or Atlanta? And when is this going to happen? What needs to occur for people to consider leaving? At what time points are people going to be considering? Are there certain critical points that we have to sort of address? And if people are going to leave, well, what does it mean as a homeowner? People buy homes to build wealth and pass it down to their children. And so what does that look like if that home is underwater? And what does it look like for renters who are often excluded from this conversation? 68% of Miami-Dade County, they're renters, and 66% of wages in Miami-Dade County pay below the median household income. And that means that these people will be less likely to sort of face this a migration need or to sort of deal with a decline in rental housing stock. And so how do we talk about equity? How do we integrate equitable solutions into our policy? And these are just a few of the many questions I have for these focus groups. And so I propose having 4 focus groups, each within 2 different community sets. One of the communities sets are communities affected by sea level rise-induced climate gentrification, as I mentioned before, and that includes Little Haiti and Liberty City, and communities affected by inundation, my own community of Shorecrest, and of course, communities across Miami Beach. Now, something that I want to add to this project is I want to film these focus groups, because it's very likely that these focus groups will be the first ever documented dialogue between scientists and sea level rise affected communities. And these conversations, they need to go beyond our focus group. And social media has shown to be a powerful tool for starting conversations and reaching beyond just a conversation you might be having with your friends. And so I want to use them to create digital stories that feature the participants and their lived experience as they are working through probably one of the most difficult decisions that they'll ever have to consider, and share it so that it can be broadcasted to other homeowners, to business owners, to decision makers inside the county, outside the county, because this isn't just a Miami problem. This is a problem for coastal communities across the nation and the world. And so my timeline for doing so, well, right now I'm currently analyzing notes from some of those community meetings I was attending all summer and looking for models of sea level rise adaptation policy. so that I can formulate my initial set of focus groups. In about a year, I would really love to have both sets completed and sort of integrating all of that knowledge into my dissertation, of course. Future outcomes. These are just a few of the outcomes that I can think of, but I'm sure there's more because I'm not sure what I'm going to find. And I do want the data to tell that story. So one of them is testing those digital stories. You know, if we disseminate this on social media, is it possible that this could change knowledge and attitudes around sea level rise adaptation? I'm not sure, so I would really love to test the efficacy of those stories. And of course, I want the data from the focus groups to feed into a larger survey about addressing adaptation preferences across Miami-Dade County. And of course, all of this would be feeding into my dissertation, which is focused on proactive policy, proactive adaptation policy in the county. Thank you so much.
Hello, my name is Natalie Burno. I'm here today representing the Engineers Without Borders Club at UCF. So the goal of Engineers Without Borders is to help the world using engineering. And that means it could be individuals, communities, or the environment. So today I'm presenting one of our projects, which is our aquaponics project located in Bithlo. So Bithlo has been in economic hardship since the Great Depression. And so as even Wikipedia can tell you, they have become known as a waste dump and pollution site. So food won't grow there in the ground. So in 2014, we began partnering with United Global Outreach to try to remedy this issue. So how aquaponics works is basically we have plants in beds, and these beds are watered by water from fish tanks, and we have tilapia in our fish tanks. So basically the waste created by the fish fertilizes the water that the plants are getting, and then the plants clean that water to take back to the fish tank. So this creates a system that sustainably sources 2 different types of food, so they can get residents of Bithlo can get protein from the tilapia and nutrition from the plants we grow in the food beds. So this creates a sustainable source of food for them. And this becomes a bit more sustainable than the normal system of farming because we don't use fertilizer and we don't use pesticides because we also have mosquito fish living there. And we also we give tours to local elementary school students so that they can learn about the system because the goal is to give the system to the community so that they can run it themselves. And that way they get involved in STEM and they learn that to take care of their environment and try to, so that they can learn new ways to reduce their own carbon footprint. So as you can see, that was one of our tours. And one of our future projects is a rainwater catchment system. So the idea with this is that we plan to add gutters to our shed so that we can catch rainwater and then filter it, so that can be another sustainable source of water for the community. And that way we could also use it for the occasional times we need to water our own plants so that we don't have to take either extremely chlorinated water or extremely polluted water. Another of our future projects is we want to create a greenhouse, and that will enable us to grow more plants throughout more times of the year, because despite the fact that it's Florida and it's warm most of the time, there are still plants that won't grow when it gets colder or in certain seasons, and this would give the community that ability. And it would also create a harmless barrier to insects, so it would be another way of preserving our plants, but without the use of pesticides. And our next endeavor would be to create to install solar panels at the site because our site does use a little bit of electricity when we turn on the lights in the fish house when we go to service that. And then in our by this summer, we'd like to be having farmers markets, a weekly farmers market, so that residents of the community can come and become more familiar with the site and source their own food from it, because the goal is to have them eventually taking care of the site, so that the community knows what its goals are and what it's doing with the site. So this is a way to start getting the community get to know each other better, and also get to know the system better and know what it provides and how to take care of it. Thank you very much.
Hi everyone, my name is Marbelys Garriga, and I would like to present to you today how hybridizing Florida's coastline, with mangrove ecological infrastructure, we can bring coastal solutions that are multifunctional and multi-purpose. So first, I would like to begin by thanking the organizations that have greatly supported me through my first year as a PhD student at FIU. FIU Sea Level Solutions Center, FIU Institute of Water and the Environment, FIU Center of Aquatic Chemistry and Environment, and Urban Resilience to the Extreme Sustainability Research Network. And also a special thanks to my advisor, Tiffany Troxler. So the city of Miami has been exponentially urbanized since the mid-1900s, converting our beautiful mangrove coastline dominated into great impermeable surfaces, like seawalls, riprap areas, breakwaters, which provide no ecosystem services and very little coastal protection. They have an expiration date as well. They're expensive to implement and create a disconnection between the land and the sea, which has a much larger impact than you may think. On the other hand, green infrastructure has many other ecosystem services and can help you regulate with water, thermal, and air quality, as well as carbon sequestration, and most importantly, habitat creation, which nurses our fisheries, as well as the aesthetic and educational value of having a greener, more community-oriented city. If that slide didn't convince you, well, this one might. It's a UN-produced figure where we have all of the ecosystem services that have been diminishing because of our mangrove loss in cover. And those ecosystem services are affecting the leaves of this tree. So on the other, in case we face impactful rates of loss in mangrove cover, those leaves are gonna be diminishing and affecting us more directly as our in our social relations, security, health, and quality of life. In Florida, we need to pay special attention to our vulnerability to sea level rise, coastal erosion, and increased pollution in waters, which is the stressor that I am focusing on for my dissertation. So at the Troxler Lab, officially known as the Wetland Ecosystems Research Lab, we have done extensive work in natural mangrove ecosystems, from monitoring nutrient, carbon, and sediment fluxes in Everglades National Park, and moving now into urban systems, as you can see in the first picture over here, which is at Matheson Park in urban Miami. For the past few months, we have also been actively monitoring waterways in the city of Coral Gables, and have noted elevated levels of nitrogen and phosphorus. These waterways deposit all of these nutrients into Biscayne Bay, which is battling eutrophication and extensive seagrass die-offs. Other experts have also noted the rapid decrease in water quality in the bay, in large part due to its proximity to the Miami urban area and the altered inland hydrology. So therefore, I would like to propose a hybrid project where we can couple green infrastructure and gray infrastructure as a way to measure how can we enhance water quality. Also, and at what rate, which is what we really want to know. Red mangroves here, as you can see, I'm not an artist, by the way, but this is my best representation for my experimental design, where we have different heights of mangrove plantings in the gray infrastructure. And we have also a confining structure, as you can see over there, these little perpendicular lines going into the coastline, that will allow us to confine those relationships between those nutrient fluxes and the cycling that we're going to be seeing. So the water quality samples will be taken out in the coast before it reaches the mangrove infrastructure. And also, as the peak of the tide is interacting with the plants, and as well as it recedes, and then we know if the nutrients are being uptaken by the plant. So all of these confinements are going to really empirically allow us to quantify all of these measurements. The experimental plots are going to be situated very nearby our natural urban areas that we have been monitoring lately. Those squares that you can see over there, this is a digital elevation model, by the way, and those squares are portraying our urban natural mangroves. So over here are my proposed sites where we were going to have that hybrid infrastructure. And they're very close by to the natural mangroves as a way for us to differentiate them, compare them, and see how they do compared to the actual natural ecosystems. So overall, my expected outcome is to look like this, where we have mangroves and seawalls at the same time. But I expect them to be well trimmed and something that's beautiful to look at, for the community to gather and see everybody and have birds and more of a happy eco-city. I'm also hopeful that if this project gets funded, future projects are more likely to be implemented, increasing the potential to transform Miami into a more eco-city, where urbanization is carefully progressed, but not at the cost of our actually natural systems. Okay, thank you very much.
Good afternoon. Thank you so much to my wonderful fellow panelists, and thank you all for being here. My name is Swiersz, and I'd like to present to you this VoLo VISTA Climate Solution, UCF and Food, which stands for UCF and the Future of Orlando's Digestion. That's a bit of a timely lunch/post-lunch time topic. This has less to do with the individual physiological process of digestion and more to do with diverting our food waste from landfills to anaerobic digesters to reduce our greenhouse gas emissions and close the loop in our food economy. There we go. Okay, so this team is made up of Mahmood. She's a second-year undergraduate in mechanical engineering, and me, I'm a fourth-year undergraduate in interdisciplinary studies. Mohsina and I are involved across the university and local Orlando and Central Florida community, and we've identified and become really passionate about implementing a solution to the immense problem that is food waste. So a recent UN estimate holds that 25 to 30% of our food globally is wasted, and that's across the supply chain. Furthermore, in our own backyard of Orange County in 2016, over 2 million tons of municipal food waste was produced. 14% of that was food waste. This poses a great climate issue. When food waste sits in a landfill, it produces a lot of methane. Now, in that pie, methane isn't the biggest piece, carbon dioxide is, but methane is a very potent greenhouse gas. For every 1 unit of methane that you emit, it has the heat trapping capacity of around 32 units of carbon dioxide. So it might be little in the pie, but it's very potent. Furthermore, in US methane emissions, food waste contributes to multiple sectors that contribute to our methane emissions, such as in the landfill, or perpetuating this fossil fuel-driven economy we have. If food waste was a country, it would be the third largest contributor to global greenhouse gas emissions. Furthermore, the International Consortium of Scientists, Project Drawdown, that's looking at the top 100 solutions to global climate change, identified the transformation of our food waste systems and reduction of food waste as a top 3 of the 100 climate solutions. So that leaves us with a problem that has clear environmental, social, and economic impacts. Mohsina and I are proposing a solution that targets both the physical and social dimensions of this food waste system that's contributing to climate change. For the physical system, we're proposing a multi-level anaerobic digestion system that targets the small and large scales at the same time of our food waste. When you're talking about anaerobic digestion, it's really just taking biodegradable material, trapping it in a closed box, an anaerobic digester, and creating from that biofuel, which can be used to power a home, drive a car, etc., and also digestate, which is just this really nice, high-quality fertilizer. So that's the physical side of it. On the social side, we're looking at 2 elements. First of all, an educational campaign. When you're talking about food waste across the supply chain, it's really about people's attitudes, beliefs, and what they do, their habits. So we're going to start at UCF and try to work on an educational campaign that can be adapted and scaled outside of our campus. We're also talking about building a consortium of academic, governmental, and private sector partners that is formally gunning towards cleaning up this issue of food waste across the supply chain. For example, with a private sector partner, there's Harvest Power. They have an amazing partnership with the City of Orlando and Disney where they take their food waste and they create energy and great fertilizer out of that. That's a photo of Mohsina, I, and some wonderful undergraduates here at UCF with Richard Day, a 2011 UCF alumnus, and he's actually the lab chemist, manages all the lab stuff at Harvest Power. So there's a lot of partners involved in this project. It's really about creating locally contextualized collaborative partnerships, right, that can work to address the specific situation we have in our coastal urban environments. Furthermore, there's a plan. Okay, so phase 1 is all about creating the social infrastructure. That way, when the physical change comes, people participate and things go well. Phase 2 is all about actually implementing the logistics of diverting our food waste at UCF from the landfill over to Harvest Power. And then phase 3 involves really just implementing, field testing, scaling up a whole pilot situation of smaller scale digesters at the UCF campus. Throughout these phases, data drives the whole process. And when we're talking about data collection in the physical sense, we're looking at pounds of food diverted from the landfill to the digesting plant or the small-scale digesters. We're also looking at then megawatts of power produced, million tons of fertilizer produced, and then we're going to take all that data and plug it into the whole life cycle of transporting, collecting this food waste through some EPA life cycle analysis databases to make sure that we are, in fact, getting a net greenhouse gas reduction. We're also looking at social data. We're measuring success by the attitudes and participation degree of individual participants and the community as a whole. Overall, this project has the potential to have a very wide-ranging impact. So we're diverting food from the landfill, we are reducing our greenhouse gas emissions, and we're innovatively creating an educational campaign and a culture of both individual and group action for change. Overall, we're looking to implement and scale this project in our UCF and Orange County communities, and then in other university, private, and governmental relationship communities across the state of Florida, and then hopefully very far beyond. So this is Food and the Future of Orlando's Digestion. Thank you very much for your time.
They're going to be here for a couple of hours, so please find them over lunch and ask the rest of those questions. Thank you.